I make a request to all my viewers. Please like and share my videos and subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem that is appearing as the question number 75 in the TS set examination held in 2023 October. The problem is from the section Algebra, and the problem is related to the splitting field, that is the extension of fields. And it is the first question on splitting fields that is appearing in this question paper. And this question is suitable for the aspirants of JL, DL, AP Set, IIT JAM and GATE. Yes, we are ready. We discuss the question number 75 with this question ID. The given question is, consider the polynomial f of x is equal to x to the power of 4 plus 2x cubed minus 3x squared minus 4x plus 2 over the field of rational numbers q. So we are given a polynomial of degree, fourth degree polynomial over the field of rational numbers. If E is the splitting field of fx over q, then the degree of E over q is. So if E is the splitting field of this polynomial over q, then required to find the degree of E over q. And we are given 4 options. Option 1, 4, option 2, 3, option 3, 2, option 4, 1. We now discuss the solution of the problem in detail. We are given the polynomial f of x is equal to x to the power of 4 plus 2x cubed minus 3x squared minus 4x plus 2 belonging to the polynomial ring over q, that is q bracket x. Agreed. What is to be found? So we have to first of all find the splitting field E of fx over q. The basic question is, what is a splitting field of a polynomial over a field? That is, we want to find the smallest extension field of q in which fx splits into the product of linear factors. Then such a field extension, that's such a smallest field extension, is called the splitting field of f of x. So our first concern is to find E, then we have to find the degree of E over q. Okay. First we ask is, where are the roots of this polynomial? Are they in q? That's the first question we ask. Right. So to talk about the rational roots, we make use of a theorem called rational root theorem. By this theorem, the possible rational roots are plus or minus factors of constant term, that is 2, by the factors of leading coefficient, that is the coefficient of x to the power of 4, that is 1. That's equal to plus or minus the factors of constant term 2 are 1, 2. The factors of leading coefficient 1 is 1 only. And then this will be plus or minus 1 plus or minus 2. Let's go and check whether f of 1 is 0, f of minus 1 is 0, or f of 2 is 0, f of minus 2 is 0. And none of them is becoming 0. But we have f of plus or minus 1 not equal to 0, f of plus or minus 2 not equal to 0. So by the rational root theorem, we do not have rational roots. fx has no rational roots. That means, in other words, fx is irreducible over q. We continue in the next slide. Right. We have that fx. We have checked now. Fx is irreducible over q. We do not have rational roots. So, now search for the roots of this equation. Now, after a careful examination, you will find that f of x is equal to the product of two polynomials of degree 2. That's a clue to you. And it is x square plus 2x minus 1 into x square minus 2. These are the quadratic factors of this fx. Agreed. So, now what are the roots of this one? X square plus 2x minus 1 will give you minus 2 plus or minus under the square root of b square, that is 2 square minus 4a1 into c is minus 1 by 2. And for this x square minus 2, the roots are plus or minus root 2. Thus, the roots are minus 1 plus or minus root 2 and plus or minus root 2. Right. Are they in Q? We do not have. They are not in Q because root 2 is irrational. It will not be there in Q. Right. We consider the extension Q root 2. Consider the extension field Q root 2. How the elements of Q root 2 will appear? A plus B root 2, where AB belongs to Q. It is a field. It is a field, and it may be observed that minus 1 plus or minus root 2 belongs to Q root 2. If you take A is equal to minus 1, B is equal to 1, then it will be minus 1 plus or minus root 2 belongs to Q root 2. And plus or minus root 2 also belongs to Q root 2. Q root 2. So that means this is Q root 2 is the smallest extension field of Q in which fx splits. What is the smallest extension field of Q in which fx splits? That will be the splitting field. So Q root 2 is the splitting field of fx over Q. So it is given E is the splitting field. Therefore, E is equal to Q root 2. What is to be found? We have to find the degree of E over Q. The degree of E over Q. What is the degree? Degree is the dimension of the vector space E over Q. So what is the dimension of E over Q? First we have to find out the basis for Q root 2. The basis for Q root 2 is 1 comma root 2. How many elements? 2 elements. So what is the degree? The degree is the dimension. The dimension basis is 1 comma root 2. Therefore, the dimension is number of elements in the basis, that is 2. So the degree of E over Q is 2. So where is the answer? The answer is appearing against option 3. Therefore, the answer to this question is option 3. Option 3, and the answer is 2. Answer is 2. So that is the detailed discussion of the solution of the given problem related to the splitting field of a given polynomial over Q. And it is from the section Algebra, and extension fields. Extension of fields or extension fields play a very important role in all these competitive examinations. So concentrate on extension fields and splitting fields and irreducibility of the polynomials. And these are some of the topics which attracts the examiner. So concentrate on that. I am sure that you have understood the solution of this problem, and I make a request to all my viewers. Please like my video in the channel and share my videos to your friends and colleagues. Subscribe my channel if you have not already subscribed. I wish you all the best. Thank you.